Powers of products and fractions. Product is the fancy math word for multiply, and we've seen it before. We talked about the product rule. But here are some products for examples. 4 times 5 is a product. 3x is a product. Even though you don't see a multiplication sign, it's right there between the 3 and the x. And a squared b to the 7 is also a product. Again, just because you don't see it, it's right there between those two powers. Well, let's use our understanding of the exponent rules to see what happens when we put a exponent on a product. So we have -2 times x to the 4. That's our product. And we're going to take all of it to the power of 2. Well, to the power of 2 means times itself 2 times. So I have -2x to the 4 times -2x to the 4. Well, -2 times -2 is +4, and x to the 4 times x to the 4 is x to the 4 plus 4 is 8. So one of the things you might have noticed is that we squared the -2, and we also squared the x to the power of 4. So this is our power of a product rule. If we have a product like x times y, and we put it to the power of a, well then that simplifies to x to the power of a times y to the power of a. Or if we happen to have a longer product like x, y, z, doesn't matter how many things you threw in there, each thing in the product gets that power. That's the power of a product rule. So let's use that to simplify 2x all cubed. So what we're going to do is we're going to throw that cubed to each of the things in the product. So that's 2 to the power of 3 times x to the power of 3. And 2 to the power of 3, 2 times 2 times 2, is equal to 8. So that's 8x cubed. So now we're going to simplify each of these expressions using our power of product rules, and we're always going to leave our answers with positive exponents. So that might require a little simplifying at the end. So let's start here. We have the cube going to -3 and to y. So that would be -3 cubed times y cubed. -3 cubed is -27 y cubed. That's part A. For part B, well, we have this whole big thing to the power of 0. And actually, we've talked about this. Anything to the power of 0 is 1. But even if we applied that 0 to every single little part of it, we'd have 1 times 1 times 1 times 1. So all of this is just equal to 1. So now that we have a negative exponent, it doesn't change the rule. You still have to throw it to each term, or sorry, I shouldn't say term, to each piece of the product. So -2 to the -4 times b to the power of 3 times -4 is -12. And again, we can simplify this. We want these to be positive exponents, so I'm going to have to flip each of these into the denominator. So that's 1 over 2 to the power of +4 and b to the power of +12. Now, if we wanted to, we could write 2 to the power of 4 instead as 16, and then we have b to the 12. Lastly, we have one more where we apply that cube into each part of the product. So we have 6 cubed, and we have c to the -4 cubed is c to the negative 4 times 3 is negative 12. So I have, again, a negative exponent, but only on the c part. So the 6 to the 3 I'll leave on the top of the fraction, and I'm just going to toss that c to the power of 12 into the bottom of the fraction, and that's equal to 216 over c to the 12. I do not have 6 cubed memorized. I just had to plug that into my calculator to see what I would get. So don't worry, you don't have to have things like that memorized. Powers of fractions have a similar rule, and we could prove this. If we have x over y cubed, that's x over y times x over y times x over y. And clearly that's 3x's on the top is x cubed and 3y's on the bottom is y cubed. So the power of a fraction rule is just like the product one, which is x over y to the power of 3, or sorry, we should say just to the power of a, to any power, is equal to x to the a over y to the a. And now let's recall that negative exponents flip the fraction. So we've seen that negative exponents flip a power and into the denominator, and it makes the exponent positive. So what that actually means is that if we have a over 5 to the negative 2, we can write this as 5 over a to the positive 2. Or in general, if we have x over y to the negative a, that's equal to y over x to the positive a. And then from there we could use our power of a fraction rule to write y to the a over x to the a. We're going to simplify each expression and leave our answers with positive exponents using these rules. So p over 10 to the power of 4, well, that 4 is going to go to each of those pieces of the fraction. So p to the power of 4, well, it's like p to the 1 times 4 is p to the 4 over 10 to the power of 4. Now, if we want to, we could expand that out, which is 10, 1, 2, 3. That would be 10, or a 1 followed by 4 zeros. So p over 4 over 10,000. The next one, well, we want to simplify this and have positive exponents. So the first thing I'm going to do is flip, because this exponent's negative, I'm going to flip the fraction. So this would be n over m to the power of positive 7. And now I can apply that power in to each part of the fraction. So that's n to the 7 over m to the 7. Finally, this one's getting more complex, but the rule is the same. I'm going to apply this 4 to the top of the fraction and to the bottom of the fraction. So I have 3ab cubed all to the power of 4 on the top, and I have c cubed all to the power of 4 on the bottom. And now I have to apply my power of a product rule, which means putting that 4 onto each of the members of the product on both the top and the bottom. And actually in the bottom, it's not a product. I'm just using the power of a power rule. So 3 to the power of 4, a to the power of 4, b to the power of 3 times 4 is 12. And on the bottom, c to the power of 3 times 4 is 12 again. I don't know what 3 to the power of 4 is. I'll throw that into my calculator. And I find that it's 81. And I probably could have done that in my head if I wanted to think about it, but I don't. So I have 81, a to the 4 over b to the 12, all over c to the 12. So that one's cool because it actually made us apply a few different exponent properties. Here we have one last example, and I just wanted to show you that we could actually do this a couple of different ways. So in the previous slide, I showed you that because I had a negative exponent, I would flip the fraction. But here I just want to show you that we can apply the rules, as long as we're following the rules, we can go in whatever way we like. So instead, what I'm going to do is I'm just going to apply that fraction, or sorry, that exponent to the top and bottom. This is equal to 3x to the negative 2 to the power of negative 3 over y cubed to the power of negative 3. So I'm just going to apply that exponent to the top of the fraction and the bottom and see what happens. As long as I don't break any rules, it's going to turn out okay. So I have 3 to the power of negative 3 times x to the power of negative 2 times negative 3 is positive 6. And then over y to the power of 3 to the power of negative 3, power of a power, multiply those together is negative 9. Well, now I've got a bunch of negative exponents, so I will have to flip things around to make them positive. So I'm going to flip the 3 with the negative exponent down into the denominator. I'm going to flip the y with the negative 9 up into the numerator. So that means I have x to the power of 6, y to the power of positive 9 over 3 to the power of positive 3. Or if I wanted, x to the 6, y to the 9 over 27.